Welcome back to my channel where math is made easy, and if you have not yet subscribed, please go over and touch that subscribe button. Leave a comment, just tell me how is this content helping you. Go like and share it with someone who needs the help. Alright, so today we're going to be doing a super easy topic. It's not difficult at all. So let's just dive right in. Identifying linear functions. And we're going to be looking at how do you identify if a function is linear, if it's done in a graph, or if it's done in a table form, or if it's done in an equation form. All right, so we're going to be touching all three. Now, the thing that you must note about a linear function, as the name suggests, if it's in a graph form, it's going to be a straight line. All right. Also, if it's in an equation form, remember for linear equations, it must be able to be written in the form y equals mx plus b. And if it's in the table form, the rate of change must be constant. So we're going to do some examples just to show you what we're talking about. So we're looking for three things. One, if it's in the equation form, it must be able to be written like that, y equals mx plus b. And two, if it's in the table form, the rate of change must be constant. And the third point is that if it's graphically represented, then it must be a straight line. All right, so let's go. Now let's look at these two graphs. Obviously, we can just point out which one is linear and which one is not. So this one, non-linear, and this one, linear. And we're stating the obvious right there. That's not a straight line, that's a straight line. So that's if it's in a graphical representation. Let's look if it's represented in a table form. How do we tell if it's a linear or non-linear function? All right, so let's look at this one. Let me put the values in. So right here is 3, 6, 9, 12, 36, 30, 24, 18. And this is 1, 3.5, 6, 8.5, 2, 9, 20, 35. All right, let's look if they're linear functions or not. Now remember we said that if it's represented in the table form, then the rate of change must be constant. What do we mean by the rate of change must be constant? It must be changing at the same value. All right, so let's look at this one. Or x for each, it's increasing by 3, and our y down here is decreasing by 6. All right, so our rate of change, they're constant, meaning that it's the same throughout. All right, so this function is linear. All right, so that function is linear because as x increases by 3, or y is decreasing by 6. Let's go to b and see if this one is linear or not. Let's check it out. So x over here we can see is increasing by 2.5. Let's check the y. What's happening with the y? So this one increased by 7, then this one increased by 11, and then that one increased by 15. Now notice the increase for y. The rate of change for y is different because it's increasing by different numbers. So we say that this function is non-linear. Why is it non-linear? And why that one is linear? The rate of change over here is constant, and this one is not constant, all right? So as x increases by 2.5, our y right here is increasing by different numbers. So our rate of change is not constant. So once our rate of change is not constant, then it's nonlinear. Let's look at if we have equations. And that's the final piece that we're going to touch. Let's look at that one. So we have 6 equations represented right here. I want you to put in the comment section which ones you think are linear and the ones that are non-linear. You can just write A, B, C and put it down there. All right? All right, nice. If you said A and E, then you're very correct. Why? Because A and E, even though it's not yet fully in the form, it can be rewritten. Can be rewritten in the form y equals mx plus b. And what do we mean by that? Let's look. If we're to rewrite this to look like this, all we need to do, get rid of the x right here, add x on both sides, that's cancelled out. We're left with 0 plus x equals negative y, which is x equals negative y. And if we want to get y, we divide through by 1. By negative 1, sorry. So that's negative x equals y, and just to rewrite, y equals negative x. It's in the form, and for some of us, we might be wondering, that's not in the form. This is really just saying that b is 0. All right, so that's a plus 0. Let's look at this one. This can be easily rewritten. Y equals x minus 1, and that's in the form y equal mx plus b. All right, so if it's an equation, how to tell? It must be able to be rewritten in the form y equals mx plus b. Now, I hope that this would have helped you. Thank you for watching.